David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you can turn on the captions and follow along with my words on the bottom of your screen. Today's topic, sine and cosine. So we're going to take a look at the relationship between these two trig functions, and that relationship comes out of the unit circle. So I've started us off here with a unit circle, radius 1, theta's down here, point P is up there. And then if you recall from previous lessons, we can drop this vertical down here, perpendicular. Our x value is there, and our y value is there. That's for point P, which is xy, which we also know is sine or cosine theta, sine theta. Okay? So think for a minute about what you might do here with the Pythagorean theorem. We have a right triangle, so perhaps pause the video, see if you can write an equation. Okay, pretty straightforward. Here's our right triangle, so we know that x squared plus y squared equals 1 squared, which is just 1. So we can write x squared plus y squared equals 1. And this is true. And so if I tell you what the value of x is, you could use Pythagorean theorem to find the value of y. Pretty straightforward. Now, we know something about x, and we know something about y. X is cosine theta, so we can rewrite this as cosine theta squared plus sine theta squared equals 1. This is our first full-on trigonometric identity. This is something that's always true for any theta in the unit circle. So if you just take the value of cosine for the theta and square it, add it to the value of sine and square it, you'll always get 1. Now I want to adjust the notation because we really don't do it quite this way. I wrote it this way because this is how we're used to writing an expression that's complicated like this. This is a function, cosine of theta. The notation that you'll see in the book, and this is what we do in mathematics, is you write it this way. Cosine squared theta plus sine squared theta equals 1. And that's how we do this. But it means this. It doesn't mean square some cosine without an angle. You have to do cosine theta and then square that. Okay? Okay. Let's use this new identity to do some math problems. And here's a very typical one that you might get. What are the possible values of sine theta when cosine theta equals 1/2? Okay, so basically we have that Pythagorean theorem equation and we just don't know one of the values. Okay, so we're going to set this up. Remember our equation is, it's sine squared theta plus cosine squared theta equals 1. So let's do some substitution. We know that cosine of theta is 1/2. So we can write the following. Sine squared theta plus, now cosine theta is 1/2. So there's cosine theta. This is cosine theta squared, or we say cosine squared theta. So that's 1/2 squared equals 1. Okay, so let's just do a little bit of algebra. Sine squared theta plus 1/4, 1/2 times 1/2 is 1/4, equals 1. Sine squared theta equals, so 1 minus 1/4 is 3/4. Now we have to take the square root, because this is the square of sine theta. So take the square root, and this gives me sine theta equals, don't forget your plus or minus, plus minus root 3 over 2. So what we're doing is we're taking the square root of the top and the bottom. Square root of 3, just leave it as a root 3. Don't get out your calculator. But 4, the square root of 4 is 2, and we do have our plus and minus. So, to summarize, if cosine theta is 1/2, if that value is 1/2, then sine theta can be plus or minus root 3 over 2. Pretty straightforward. Let's throw that on the unit circle so you can see how that looks graphically. So this is a unit circle, so we know this distance is 1, right? So cosine theta is 1/2. Remember, cosine is your x value, so cosine theta is right there. So that is 1/2. And then the y-coordinate will be the positive root 3 over 2. So this is root 3 over 2. Now there's two possibilities, right? We have a plus or minus, and that's pretty simple. That's just this one all the way down. And this one would also be positive 1/2 for the x, but now we're minus root 3 over 2 for the y. Okay? So solve this algebraically, then we threw it on the unit circle to see how that plays out. Okay, let's try another problem. We're going to get a little bit more complex, so follow along, pause the video, do what it takes to understand. Or write down a question and bring it to our next class. Okay, so it's saying, find the exact value of cosine theta if sine theta is 3/4 and pi over 2 is less than theta is less than pi. So there's two things I want to talk about before we jump into this problem. The first one, when they say exact value, what they mean is don't put a square root into your calculator and get a big long decimal expansion. Once you do that, it's no longer exact, it's an approximation, because you can't write out all the decimals that are there. So leave the roots in your answer, just like we did with that last problem. Second thing, it says, and theta is bigger than pi over 2, but less than pi. Now we know theta is an angle, okay? So we know we're talking about radians, because it could say some degrees here and degrees there, and they're only interested in the theta that's between these two degrees. And essentially that's what they're saying, they're just using radians instead of degrees. So let's review. To go all the way around the unit circle, that's 2 pi radians. So 1 pi radian is 180 degrees, and pi over 2 is 90 degrees. So another way to think about this phrase is it wants the theta to be between 90, bigger than 90, but less than 180. So they're only looking for theta in that range. Okay, let's get started solving this. Our first step is just going to be to use the identity sine squared theta plus cosine squared theta equals 1 to figure out what cosine theta could be, and then we'll take a look at the range to figure out if we need to toss out any of those values that we get. So, the first thing we have is sine squared theta plus cosine squared theta equals 1. Let's substitute in. We know that sine theta is 3/4, so sine squared theta is going to be 9 over 16 plus cosine squared theta equals 1. So I just plugged in 3/4 for sine theta and squared it to get 9 over 16. Subtracting 9 over 16 from each side, I get cosine squared theta equals 7 over 16. And then take the square root of both sides. Cosine theta equals root 7 over 4, and there's a plus minus there. Okay? So just like the last one, we left this in root form. We did not pull out the calculator and get a decimal, and that's what this means. Exact. So leave these roots where they are. Okay, so now we know what cosine theta can be. It's plus or minus root 7 over 4. Now we need to deal with this. And the way I'm going to do that is I'm going to throw this on the unit circle so I can see what's happening. Okay, so theta needs to be between pi over 2 and pi radians, which is 90 and 180 degrees. So we're looking for some theta that's over in here. So I'm just going to draw sort of an arbitrary radius there. I'm not sure if that's exactly right, but it's close enough for the purposes of solving this problem. So sine theta is 3/4. So remember, sine is the up and down. So that's this distance here. That's 3/4. The x distance is going to be plus or minus root 7 over 4. Now, we know we're in the second quadrant. So this has to be minus root 7 over 4. right? The plus root 7 over 4 would come over here, but we're not interested in that one, okay? So, we have our answer. We can scratch out the plus for cosine theta. So it can only be negative root 7 over 4. So find the exact value of cosine theta if sine theta is 3/4 and theta is between pi over 2 and pi radians. So we did that. Okay, this next point builds on some work we did in the last lesson where we analyzed what the sine, S-I-G-N, of the various trig functions were as we considered different situations with different values of theta. So now we're going to come up with a nice way to memorize what the sine, S-I-G-N, of those three trig functions are. So let's take a look. Quadrant 1. We know that sine and cosine are going to be positive. They're going to be above the x-axis and to the right of the y-axis. So in quadrant 1, it's all. I'm just going to write the A for all, because I'm going to make an acronym. In quadrant 2, we know that sine is positive because it's above the x-axis, but cosine is negative because it's to the left of the y-axis. So here, sine is what's positive, only sine. If sine and cosine have different SIGN signs, then you know that tangent is negative. So here it's sine. In the third quadrant, we've come all the way around. Now we know that both sine and cosine are negative because we're below the x-axis and we're to the left of the y-axis. So those are both negative, they're not positive, but if they're both negative, then tangent is positive. So we put T for tangent. So when are sine, cosine, and tangent positive? In quadrant 1, it's all. In quadrant 2, it's sine. In quadrant 3, it's tangent. And then let's get over to quadrant 4. We know that the x direction is positive. The x coordinate anywhere along this arc is positive. So that means that cosine is going to be the one that's positive. Sine is below the x-axis, so that's going to be negative. And then when cosine and sine have different SIGN signs, then tangent is negative. So here's our acronym. And what the book uses for that is all silly turtles crawl. Now, if you want to come up with a more fun or unique or personalized acronym to remember this, that's fine, and you can bring them to class next time and share them, see if we can get a laugh. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.